In this video, I'm going to show you how to use elimination to solve a system of two linear equations. So here's our first problem. We want to solve the following system of linear equations. First equation is 2x minus y equals 2. Second equation is x minus 3y equals negative 9. Now the whole idea behind elimination is that we add equations in a way that cancels a variable. But first of all, let's talk about adding equations. So adding equations is something that we're allowed to do because an equation by definition is an equality. And so if we're adding equal amounts on both sides, the equality is still maintained. So we could, in theory, just add these two equations together and get a third equation, 3x minus 4y equals negative 7. And that would be a perfectly valid equation for this system. But of course, that would still have two variables in it, so it wouldn't help us too much. So the idea here is before we add these two equations, we're going to multiply each equation by something so that when we add them, one of the variables will cancel and we'll be left with a single variable equation. So how will we make some variables cancel when we add? Well, one option is to look at the x's. We could multiply this bottom equation by negative 2, so that way there would be a negative 2 on the x, and that would cancel with the 2x when we add. Or we could do something with the y. We could multiply the top equation, say, by negative 3 to get this negative y to become a 3y, and then that would cancel with the negative 3y. But why don't we do the first thing just for the sake of this example? Let's take this equation and let's multiply it by negative 2. So let's write that down. Times negative 2. And what's the resulting equation? Well, negative 2 times x is negative 2x, and then negative 2 times negative 3y becomes plus 6y, and then negative 2 times negative 9 is positive 18. Now the top equation, let's just keep that the same because we want to keep that 2x the same to cancel with the negative 2x. So it's just like we're multiplying by 1, say, and we still have 2x minus y equals 2. And now here comes the fun part. We get to add the two equations. And if we multiplied by the right strategic amounts, then a variable should cancel here. So we'll add the two equations together. 2x minus 2x, well, that cancels, and we have 0x. And then negative y plus 6y, well, it's 6y minus y, that's just plus 5y, and then equals 2 plus 18 makes 20. So 0x, we can just forget about that entirely, just scratch it out, and we just have 5y equals 20. So to solve for y, we can just divide both sides by 5 here. Divide by 5, that will cancel with that 5 on the y, and we'll just get y equals 20 divided by 5, which is 4. Let's circle that so that we don't forget it. Now that we have the solution for y, we need to find the solution for x. But that's pretty straightforward because we can just plug this value of y into one of these equations that we have here and then just solve for x. Why don't we use an equation that is simplest to solve for x? How about that one right there? Because that just has just a single x, no coefficient in front of it. So let's go ahead and plug in y equals 4 into this equation. And the resulting equation here will be x minus 3 times 4 is equal to negative 9. So we just go ahead and compute and solve. So x minus 12 is equal to negative 9, and then just add 12 to both sides, plus 12, and the result is we get this 12's cancel, and we get x equals 12 minus 9, which is 3. So x is 3. So there we go. There is our solution. X is 3, y is 4. We can write that as an ordered pair of x, y. Just write it 3, 4. And there we go. There is our final solution to the system. Okay, next problem. Now let's solve this system of linear equations. 5/14 x equals a half plus 2/7 y, and negative 2y equals negative 4/3 x. So this system is clearly more challenging because now we have fractions in here, and also the equations are kind of jumbled up. We don't have x and y on the same side in both of the equations. So for our first step, why don't we get rid of the fractions in these equations? Now we can get rid of the fractions by multiplying each equation by its least common denominator. So let's take a look at the top equation first. So there's 2, 7, and 14 in the denominators here. And what is the least common multiple of 2, 7, and 14? Well, it's just 14. Both 2 and 7 go into 14, and 14 is the lowest we can go here because one of our numbers is 14. So let's multiply this equation by 14 to eliminate those fractions. Times 14. Our result here, 5/14 x times 14, well, that just gives us 5x, and that's equal to a half. A half of 14 is just 7, and then plus 2/7 times y. Okay, well, what's 1/7 of 14? Well, 1/7 of 14 is just 2. So 2/7 of 14 is 4. So plus 4y. Now let's do the same thing with the bottom equation. That's a lot easier because there's only one denominator, that's 3. So let's go ahead and multiply by 3 times 3. So negative 2y times 3, that makes negative 6y. Then that's equal to negative 4/3 x times 3. Well, 3 cancels the 3 in the denominator, and we just have negative 4x. Okay, now let's rearrange these equations a bit, get the x's and the y's on the same side. So let's put all the x's and y's on the left-hand side like usual. So in the top equation, we will subtract 4y from both sides, and that'll just give us 5x minus 4y is equal to 7. And then in the bottom equation, let's just add 4x to both sides and get 4x minus 6y is equal to 0. Okay, great. So we've cleaned things up a lot. Why don't we write this again on a new row, just so we have a new row to actually perform elimination. So 5x minus 4y equals 7, and 4x minus 6y equals 0. Alright, so now we want to actually perform elimination, and how can we do this? Well, let's look for a variable that we can cancel. Immediately, something pops out, this minus 4y and this minus 6y. If we bring one of those to 12y and one of those to negative 12y, then they can cancel. And that'll be straightforward because 4 and 6 are both factors of 12. So why don't we bring, say, the top equation to positive 12y. What do we need to multiply to get there? Well, negative 4 times negative 3 makes positive 12y. So we'll multiply by negative 3 on the top, and we'll get negative 15x, then plus 12y equals negative 21. And then how about on the bottom, if we want to get to negative 12y to cancel with this positive 12y, just multiply negative 6 by 2. And the resulting equation is 8x minus 12y equals 0. Great, so now it's the fun part. We get to add the equations and something should cancel. We've done this right, so the 12y and the negative 12y, these cancel. We get 0y, let's just not bother writing it at all. And then we'll have negative 15x plus 8x. Negative 15 plus 8 is negative 7. So we have negative 7x equals negative 21 plus 0, which is just negative 21. And now we can just divide both sides by that negative 7 that's on the x. Divide by negative 7, that cancels out, and we just have x is equal to negative 21 over negative 7, which is 3. There we go. So we've got what x is, and now we just need to figure out what is y. So again, we can just substitute this x equals 3 into one of the equations we've got here. Any choice will do, but this one's closest to us. Why don't we just substitute it into here? So bring that x equals 3, put it in there, and the resulting equation is 4 times 3 minus 6y is equal to 0. Evaluate that, that's 12 minus 6y is equal to 0. And then how about subtract 12 from both sides? Minus 12 minus 12. And that way the 12 cancel with the minus 12. We just have negative 6y equals 0 minus 12, which is negative 12. Then divide both sides by negative 6. Divide by negative 6. That'll cancel out the negative 6 on the y. And we'll just have y equals negative 12 divided by negative 6, which is 2. So x is 3, y is 2. And we can write that as a single ordered pair, x comma y, that goes 3 comma 2. Here's our final problem. We want to convert the following system of linear equations into a system with integer coefficients and state the single variable equation obtained after elimination. Here's our system. 2x plus 0.3y equals negative 1.4, and 0.04x plus 0.12y equals 0.2. Now you'll notice that, of course, this system is pretty challenging because it has lots of decimals in it. And just like fractions, decimals make things messy, so we'd like to convert to integers first before we try to do elimination. Now this time we're going to stop once we get the single variable equation after elimination. And that's just because finding the full solution to the system will take a bit more time, but we know that if we get to the single variable equation, then it's really straightforward to find the solution to the system. All we have to do is solve the single variable equation and then back substitute to find the value of the other variable. So our first step now is to convert this system into a system of equations with integer coefficients. So now let's take a look at each of these equations here and see how we can convert it. So the first equation, this has 2x, that's already an integer, but this 0.3y and this negative 1.4, those are problematic. Now the trick here is just to notice what's the most number of places behind the decimal. Like this 0.3, that only has one place behind the decimal, and this negative 1.4, that also only has one place behind the decimal. So we just need to move the decimal one spot to the right. And the way we can do that is by multiplying by 10. Multiplying by 10 moves the decimals over to the right once. So if we multiply by 10, that'll turn both of these into integers. So let's go ahead and do that. Times 10, and the result, 2 times 10 is 20, so 20x, and then plus 0.3 times 10, well, just move the decimal over once to the right, and then that's just 3 point, so just 3, so 3y is equal to negative 1.4 times 10. Again, just move the decimal place once over to the right, so negative 1.4 point, which is just negative 14. Now for the second equation here, it's really just the same idea. So we're going to be multiplying by something to move the decimal place so that there's no decimals left. Now let's take a look. This time we've got something like 0.04, and that's two numbers behind the decimal. 0.12, again, that's two numbers behind the decimal. 0.2, that's just one number behind the decimal. But we find that two numbers behind the decimal is the most numbers behind the decimal, so we need to move the decimal place over 2 to the right. And we can do that by multiplying by 10 twice, or really just times 10 is just times 100. So times 100 will move that decimal place over to the right. And you can see the pattern here. Multiplying by 1 with 2 zeros after it moves the decimal place over 2 to the right. The number of zeros just tells you how many times to move the decimal place over. So let's go ahead and do that. So 0.04 times 100, move that decimal place over 2 to the right, moves there and then there. So it's really just 4 point, so just 4x. And then same thing with the 0.12, so move that decimal place over twice, so 1, 2, and we just got 12 point, so just 12, so plus 12y is equal to, now be careful here, it's tempting to say this 0.2 times 100 just becomes 2, but that would not be right because there's actually zeros after the 2 here. It's like 0.2, 0, 0, 0, 0, so on, so we need to take into account the 0 that's after the 2, and now when we move this decimal place over twice to the right, we go 1, 2, and we've got 20 point, so it's really 20. Okay, great, so now we've got our system with integer coefficients, and now let's actually eliminate on this system. So let's see, what can we eliminate? Well, we can eliminate this x here if we get this 4x to be minus 20x. And in order to do that, all we have to do is multiply by negative 5. So let's multiply this bottom equation by negative 5, so times negative 5, and we'll have negative 20x, and then 12 times negative 5 is negative 60, so minus 60y, and then that equals 20 times negative 5 is negative 100. And this top equation, that'll just stay the same, so just like times 1, same exact equation, 20x plus 3y is equal to negative 14. Alright, so now we just add these two equations and we should be done. So 20x minus 20, that just cancels, that eliminates, we've got 0x, so just ignore it totally. And then 3y minus 60y, well, think the difference between 3 and 60 is 57, but 60, the bigger number, has the negative on it, so negative 57. So negative 57y is equal to negative 14 plus negative 100, just negative 114. And there we go, there's the single variable equation obtained after elimination. We could just solve that for y, then plug our solution into one of these equations to solve for x, and then we'd be done. Now, if we were to continue solving this equation, we would get to y equals 2. And then if we back substituted to find x, we would find x is equal to -1. So that way the total solution would be the ordered pair -1, 2. And you should check this for yourself to get some good practice. Great, so now we know how to use elimination to solve a system of two linear equations. And in the future, we'll continue to learn more about systems of linear equations, such as how to use them to calculate the intersection of two lines.